So like this, we can give that what CNS fourth year person. So email ID కూడా చాలా క్లియర్ గా ఉండడానికి అలాగా సింపుల్ గా ఇచ్చాను @gmail.com. Then subject you can type it as your register number 17B8 is there no 1A 11201 something is there no like that, and we can starting with the CNS underscore A1 and A2. So by this specification, I can see that the subject itself. I can know that. So you are the person. The number wise, I can identify your assignments. So we can save as same name itself. A1. So that is one, and another also A2. So similar, same this one also. So common format I am giving. Don't confusion with other formats, and don't delay with this. Okay, like that you can make it as a subject, and we can send to mail. That mail ID I think I forwarded in your chat box. Have you got it or not? So this is the way you can, and you can attach the PDF, one PDF for one assignment. So give the names as these names. So this for assignment one, this for assignment. So like that everyone has to submit assignments as soon as possible. So I already given 2 weeks back itself assignment 2 also. So everyone send the soft copies to here, and keep it hard copies ready with you. Whenever you are coming to college, that time you need to submit it. Okay. So anyone having doubt still? You can tell me, or I will close it. So anyone having doubt still? How to submit a CNS assignments? So if you don't have, you can go through the next unit. I think Lakshmaji sir is handling unit 5. So that is a security part 1, and this one is a security part 2. So this one network security part 2. So that is a part 1, and this is a part 2. There we are going to be learn PGP various protocols. Same here we are going to be see about internet protocol security, how we are going to be see. Then how the system security. So for that, initially we need to know about what is internet protocol, that is IP. Then how we are going to be provide IPsec, that is IP security. So how we are going to be provide the IP address security, how we are. So here we have to learn about so various types of IP addresses are there. So how we are going to be identify the type of IP address, then what is the header length, and how we are going to be I transform all those things data through this. So this is our total unit itself, very small unit only, but we have to learn a lot in this, and we have to remember the previous network concepts also. Even if we know what are the layers of ISO model, what are the 7 layers or 8 layers, total how many layers are there? Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So total 7 layers are there. No? That 7 layers how the data is transferring. In each layer, what is the format of data? For simple example, in the physical link layer, we have a representation of it. In data link layer, we have a datagrams. Next, we have a packets. How we are going to be send the data in a various formats. So that I think you everyone remember that formats are. Or shall I go with that layer architecture once again? Can anyone answer? Based upon that, we can proceed with. Or else we can directly enter into this IP security. Or else shall I show you that OSI layers, how the data is going to be transferred? So response please. What shall I go or not? Okay, even we will discuss. If anything needed, we will back and we will learn. Okay? No one response, I cannot do anything. So this total unit we are going to be see about internet working and internet protocols, and the IP security overview and IP security architecture and authentication header and encapsulating security payload and the combination of security association, and the last one is about key management. So these are the things we are going to be discussing in this unit. So first of all, we have to go with what is this internet working and the internet protocols. So what is internet working? Internet working. What is the meaning of networking? Then we can have internet. So networking is connection of one or more systems, we can call a network. So what is the use of networking? In order to transfer the data from one node to another node, so we are going to be use this networking. So here various ways of sending, that is maybe connectionless and connection oriented, many ways we are going to be send the data. So how we are going to be working with this? So for this only we have to learn about these layers. So if the person, the node A, the sender is going to be sending the data, that means he is going to be prepare the data and he is sending the data from his system to some other destination system. So if the data is creating by the user, then how the data is going to be transferred through the network. So as basic, we know that the data is digitally formatted and each and every bit wise it is going to be transferred through the network only. So similar how the uh, power is going to be, the current is going to be transferred through the electrons and protons. So electrons are how it is transferred. Same here also, the data is going to be transferred. So like a digital, that is zeros and ones, how it is going to be transferred. So if the data is created at a high level, that is maybe in English, for example, you are writing an email to your friend. So if I are writing the mail in a high level English, the computer can understand only the zeros and ones low level. So if the high level language English, how it is going to be converted into a lower level language, then the lower level language, that bits is going to be transferred through the network. Then the bits is collecting, and again other side is going to be shown again as a English format only. It is not going to be shown as zeros or ones. So that's only it is, the data is going to be transferred from one system to another system. The data must transfer these 7 layers. So that is, for example, the user A, that is a sender, is creating through the application layer is going to be created. So that is the email creation, SMTP, simple mail protocols, and MMTP. Various protocols are going to be used to create the data by using application layer. From application layer to, we are going to be sent to the presentation layer to session layer, and session layer to network layer to transport layer, and transport layer to data link layer. So that is up and up. That is a transport. Next, network layer, then network layer to data link layer, data layer to physical. In the physical layer, the data is going to be represented as a bits. That bits is going to be transferred from physical media through physical media, not from through physical media we are going to be transferred. And the other side, the 7 layers is opposite way. The physical layer is going to be other side. The sender is going to be sending, and the receiver side, same 7 layers. Reversely, it is going to be get the data. How it will be? So after physical media transfer the data to the receiver, the receiver side, a physical layer is going to be get the bits, and it is going to be combined into datagrams. That is going to be a duty of data link layer. Then the data link layer to network layer to transport layer, then transport layer to uh, session layer, and the session layer to presentation layer, and presentation layer to application. So like this, again the top of the presentation layer, it shows the how the data is going to be presented is a common. So this is a simple data transferring. So in order to transferring these data, we need to provide a security for this. So for that only here we are going to be simple protocol, internet protocol. So we know what is a protocol. So protocol is a set of rules governed by the network. When we are going to be transfer the data in the network, the protocol should be followed. So some set of rules is going to be framed and how to transfer. So every protocol has a format in order to send the data from one node to another node. Definitely they have to know the data from where it is going and where it is sent, from where it is coming and where it has to go, and what is the size of the data, and what is whether it is properly checksum is done or not, whether we have any optional padding also there. So like that, various views we are going to be check the data in the general format. So for that we are going to be use the internet protocol. So simply we will call as it is an address. So for example, we are sending a letter to your friend. So that is offline. That is a general way of, we are not going to be talking about node to node transfer. We are going to be talking about people to people. So when we are going to be talking about people to people, what is going to be happening? For example, if I want to communicate your one of my friend. So how, for example, we are not going to be talking about any communication services. Simply we are going to be use a letter. So if I am going to be send a letter, must I need to send a letter through from and to, I need to mention. So the postman received that letter, and he has to send each node, and he is going to be transfer the exact person address he is going to be. The same way, if we are sending the data in a digital format, here also the sender has to know the destination address. Then the address must be mentioned in the data. Then the data is going to be transferred to the network. So like that we have here. So here we have internet protocols. Two versions are there, IPv4 and IPv6. So based upon the version, we have various sizes were mentioned. So that we will see. Today we will see that internet working and internet protocols. So what is this internet working and internet protocol? The internet protocol, sir, sir, I know. So internet protocol is a principle for communication protocol in the internet protocol suite for relaying datagram across the network boundaries. Its routing function enables the internet working and essentially establish the network. Essentially establish the network. The internet protocol is a principal communication. So communication purpose we are going to use. The protocol suited for relaying a datagram across the network boundaries. It is routing function enables the internetworking and essentially established in the internet. So have you remember that capital I and small I, capital internet and small I internet. So if you not clear, you can go through and clear it properly. So inter means local, intra means external outside, so that we can the basic level of internet. Now this IP has a task of delivering packets from source host to destination host slowly based on that is own response. So slowly means that is slowly, that is own response based upon IP address on the packet headers. For this purpose, IP defines the packet structure that encapsulate the to deliver data to be delivered. So it is also defined addressing methods that are used to label the datagram with source and destination information. So IP has a fast delivery. So what is the purpose of this means? So it must have to source and destination addresses and slowly own responsibility of sending the data from one place to another. It defines the addressing methods. So it is used to label the datagram with the source and destination. So every, I already told you, every protocol has a header information such that the header contains uh, from where the source address and destination address and what is the size of message, and various information is contained in every message header. So the Internet Protocol is responsible for addressing host interface, encapsulating a datagram, including fragmentation and reassembly. So what is this fragmentation and reassembly means? So if any gaps in between the messages to message, or we have to reassemble. For example, so for this we have one simple thing. For example, puzzle game we are going. So even if that is the next slide, we have that simple meaning of this reassembling and fragmentation. I will show you. And routing datagram from the source host interface to a destination host interface across one or more IP networks. For these purpose, the Internet Protocol defines the format of packets and provides an addressing system. So I already told you where is the here we are going to be talking about datagram, packet, and representation of bits. All those things. These are the functionalities of each and every layer of this OSI links, every layer of OSI links. So like that, we are going to be transfer the data. So if we are going to be transfer, how much this Internet Protocol is going to be responsible for this addressing, responsible for sending the data from one node to another node. So what is the responsibility and role for that? So each datagram has a two components, that is main. So that is each data, that is a datagram means one packet of data, one data. So contains two components. So what is the header and another one is a payload. So the IP header includes the source IP address and destination IP address and other metadata needs to route and deliver the datagram. So deliver the data. The payload is the data that is transported. This method of nesting the data payload in a packet with the header is called encapsulation. So this is known as encapsulation. What is we have generally known as what is encapsulation? So it is one of the used concept. No? So that is so how we are going to be transferred. This method of nesting the data payloads. So every datagram has a two parts, that is header and payload. So how the payloads are going to be transferred with the nesting of one. Nesting means combining one. So that is a simple meaning of we talk about fragmentation and reassembly. So that is the concept of reassembling. So IP addressing is entails this assignment of IP address and associated with parameters of once again. Okay. So IP address is entails with the assignments of IP address and associated parameters and host interfaces. The IP address space is divided into subnetworks and involving the designation of network prefixes and IP address routing performed by the all hosts as well as the routers. The host main function is to transport packets across the network boundaries. So routers communication with one another via specially designed routing protocol. Design routing protocol. So either the interior gateway protocol or exterior gateway protocol. So as needed for the topology of the network. So again, we need to know about what is the topology we are going to use. Do you know what are the various topologies are available? Can anyone? Can you remember the topologies? Topology. What is the meaning of topology? So I will give the names: bus topology, mesh topology, star topology, ring topology. I remember these topologies. So that is how the connections are made. How the connections are made. So if we have taken one backbone network, through that backbone network we can connect all other systems. So that is known as the bus network. And the star network is, so star means definitely one system is going to be connected with all other systems like that. Then ring topology, one after one connection. So by the name itself, we can understand that what is the connection of that network in a topology manner. So this is a simple thing about how the data is going to be transferred in the network. For example, if you take the data link layer, so we have a frame footer and a frame header and the frames of data. So then it comes to the internet protocol, that is the internet layer. It comes. It has an IP address, IP header. That is the IP header and IP data. Then the transport layer, we have a UDP header and UDP data. So I already told you there is each and every layer we have a various different way of representing a data. For representing each and every data, there is a specific format for from where it is coming and where it has to. So that is a simple meaning of header, means it contains. So next slide we will see about what is the header format also we will see. So there we can learn about. So whatever the data is transferring through the layers, so it must show. So I already told you the application layer is going to be create the data. Once the data is created, it is going to be transferred. So here the session layer and application layers are option. So it is the format of TCP IP format only. So in OSI layer format, we will see all the 7 layers. In this format, we will options of presentation layer and session layer. So that is simple. The data link, the application layer is going to be creating the data. The data is sending and it is providing the UDP header. We are going to be talked about from top to down. So top to down means the creating data to sending data. Then IP address, IP header format, then the frame format, how we are going to send. So this is a simple networking example for how the system is sending data from one system to another system, end system and so we have, for example, two systems are there, two end systems. One is a sender and another one is receiver. So when we are going to be talking about just sending data from one place to another place, so here we may say that end system is one end system is a server and another end system is a another receiver. That is a sender and receiver format editor. So if we have a LAN connection, so that is a LAN we are using. For example, here the LAN is a backbone network. One network where we connected all the systems. So end system and we have a router. From this router we have some wireless point of view. We have maybe we have a LAN and WAN or any point-to-point network we can directly access. And the router 2 is going to be accessed and another end system is going to be. So if you talk these one in a layers manner, so that is a physical layer and data link layer and transport internet layer and transport layer and application. So if you talk about this one, how we are going to be transferred. So physical layer and we have a MAC message authentication code and layer link layer. So then the IP address, we have various formats. How we are going to be send the data from one layer to another layer. So each and every layer is responsible for a data header. So from where it is coming and where it is going, and what is the size of the data, everything we have to mention. So now I will show you what is the header format. So before going to this, we'll see what is this TCP/IP. So we know the ISO, OSI, ISO, OSI layers. Even if we have a TCP/IP layers also there. So what is the use of this TCP/IP means? The internet protocol, that is IP. Even that's internet protocol, that is the address system. The internet and has a core function of delivering packets of information from source to target system. So that is the simple meaning of this internet protocol. This is the responsibility of delivering packets from one system to another system. So if IP is a primary way which the network connections are made, it is established basic basis of the internet. So when we have a connection of internet, so this is the IP address is a basic functionality of connection network, and we are going to be sending it. So IP does not handle the packet ordering or error checking. Such functionalities requires another protocol This is typically is TCP. So that is a transmission control protocol. So just we are going to be addressing purpose on delivering packets. Okay, the packet is taking from the source to destination. So these two parts only we are going to be dealing with the IP address. But we have to check with the primary, the connections are established by the IP address. But we are not going to be talking about error checking. Such functionalities require for another protocol. So that is known as TCP. So what is this TCP IP relationship? Is similarly to send someone a message written in a puzzle through a mail. So what is the meaning of puzzle? So even if I gave a clear explanation about how the puzzle. So message is written down and the puzzle is broken into pieces. So message we are going to be write a puzzle, then the puzzle is going to be broken into pieces. Each pieces then can travel through the different postal routes, some of which take longer than other. So maybe based upon the path the packet is chosen, maybe it's taken time to deliver is different. When the puzzle pieces arrives after transferring their different paths, the pieces may be out of order. So it is not in a proper order. The internet protocol makes the pieces arrive their destination address. So internet protocol, what is the? It is simply is transferring the data from one source to destination. That is so. What are the that is a email. The email is a puzzle that is broken into different pieces. The pieces are taken in a different routes. So these root concept we can have that is in a data structure we may learn about spanning tree algorithm, depth first search and depth first search. We have learned so many algorithms how we are going to be data is transferring from one node to another. So there is a in-depth concept of that one. So if there is selecting of different ways that the data is sending and finally it is going to be received the destination address. So that is the main duty of internet protocol. So whatever it may be, it is definitely it is in a out of order. So because based upon the way the chosen some more puzzle pieces are going to be received early, some more puzzle pieces are receiving later. So the TCP protocol can be taught as a puzzle assembler. I told you, no, assembler. So assembler on the other side, which puts the pieces together in the right order. So IP is going to be a responsibility of sending the data from one place to another place. Okay, that is the main purpose. But we don't know about the IP. Don't know what is the order and what how to make it into a proper. So that is the framing and checking all those things. It is not a responsibility of that. So by using the TCP protocol, it is going to be puzzle assembler on the other side, which puts the pieces together into the right order. So ask for missing pieces to be resent. So if any pieces is missing, it is asking to resend, and it sends. Uh, let's know the sender know the puzzle has been received or not. So the sender puzzle is received or not, or is properly. So what exactly mail is sent and is broken. So that broken pieces are all are sended properly or not, and is received is good. So TCP maintains the connection with the sender from before the first puzzle piece is sent after the final piece is sent. So there is another interesting topic is about acknowledgement. How what is the meaning of acknowledgement? For example, so every class starting of the class I ask whether my voice is audible or not when I am asking. So what for I am asking? So whether my connection is properly is there or not. So then what I am asking, so my voice is clear, somebody is responding. So then I can know that my voice is clear to all, my voice is sending properly to all of them. So by that I am going to be get the acknowledgement from you. So someone is responding back, then I can know that so my voice is reachable to all of them. So by that I am going to be check it. So that is a acknowledgement. So here we have a handshake responses are there. So I will show you one simple diagram for that also. So IP is a connectionless protocol, which means that each unit of data is individually addressed and routed from the source service to target device. So each and every unit of data have a header part. So the header part contains what is the source address and what is the destination address, what is the size of that particular message. Everything information will be available. So a device, target device, the target does not send any acknowledgement back to the resource. That's where the protocol such transmission control, transmission TCP transmission control protocols comes in. So the TCP is used in conjunction with IP in order to maintain the connection between the sender and the targeter, ensure the packet order. So in order to make the packet order, we need to confirm with this order maintaining. So target system, we need this TCP. For example, see this example, we can have a clear idea about what it is. So when the email is sent over TCP, the connection is established and the three ways of handshake is made. So simply when we met in a person, how are you? So how are you? So then how are you? Okay, I'm fine. Okay. So again the question back is how are you? So that is a three-way. The handshake algorithm here. The first, the source is sending a send as a synchronization message, synchronization initial request. The packet to the target server in the order to start as a dialog. Then the target server then sends the synchronization back, that is SYN synchronization acknowledgement. So the ACK is called an acknowledgement, a synchronizer acknowledgement packet to agree agree to the process. Lastly, the source sends an ACK packet to the target to confirm the process, after which message contents can be sent. Okay, so before sending the data, before itself we have to confirm that the whether, for example, if I ask, so I am from, for example, I am from Eluru. For example, simply you are telling I need to send the data to, for example, Delhi. So when the person is met, so you are from Delhi. So once the connection is established in between, so the proper acknowledgement is coming from the receiver. Then the person, that is the source, is ready to send the data to the receiver. So the email is ultimately broken into a number of packets, and each packet has a sent out of the internet, where is the traverse a series of gateways before arriving the target device, where the group of packets are reassembled by the TCP/IP by using the original connection as a key. So that is, for example, you see here the three ways of handshakes are there. First one is about synchronization. So through that synchronization, he is giving acknowledgement back. Okay, acknowledgement is back. Then so he is giving, he is ready to, okay, acknowledgement is received. He send back, okay, you are the right person. Then the person is ready to send the data. So the primary version of IP used internet today, the Internet Protocol version 4, that is IPv4, due to the size constraint with the total number of possible address IPv4, a newer protocol was developed. The newer protocol is called IPv6, and it makes many more addressing available and increasing in adapting. So what are the things we will see? So first we will see what is IPv4. So this is the IPv4. That means each and every data packet which we are sending in the network, every data packet should contain these information. So that is what is the version, what is the IHL and type of services, and total length and identification, what is the flag, fragment offset, and time to leave, and protocol, and header checksum, and the source address, destination address, and option and padding. So these total size. So I this is the no, version is a 0 to 4 size. So we have somewhat confusion. I have another diagram for this. So what is the particular version? How many bits is available? So IHL, how many bits? Types of services are total. So I will show you this diagram. For exam purpose, you can write. For learning all those things, I will show you one more diagram that will give all those things. So IPv4 is a connectionless protocol. It is used a packet switching network. It operates the best effort delivery model, which either delivery is guaranteed nor a proper sequence or avoiding the duplicate delivery is assured. So that is whether the multiple times we have received the message or multiple times we are sending the message, that also. So it is not only giving a guarantee on the delivering, it is giving the delivery whether the duplicates are there or we need to send it back, any missing packets are there, that also it is good. So Internet Protocol version 4, the fourth version of the Internet Protocol, the widely used the protocol is data communication over the kinds of network, different kinds of network. So IPv4 is a connectionless protocol used in packet switching layer network such as Ethernet. It provides the logical connection between the network devices by providing the identification for each device. There are many ways to configure IPv4 with all kinds of devices, including manual and automatic configuration depending upon the network type. So like for example, in a lab when we are doing, so everyone please set your IP address back, and you can change your IP address. So if any IP address is changed, I think if you remember with the doing with the lab, there we are going to be. So today IP address is changed. So instead of using 192.168.9.180, we can use 192.168.9.181 we can use. So maybe that particular one is busy with the other programming, we can go with this one. So that is way of how we are going to be. That may we can do manually or we can do directly also. So that is based upon the configuration settings we can. So IPv4 defined and specified by this IETF, that is an Internet Engineering Task Force, published in RFC 791. That is a publication they was mentioned. So IPv4 uses the 30-bit addressing mode, Ethernet communication, 5 classes. We know what is the IP classes: Class A, Class B, Class C, Class D, Class E. Class A, Class B, Class C are the different bit length for addressing network host, and the Class D are the reversed for military purpose, and other Class E address are for reversed for the future use. These are the different way of organizing these IP addresses. You know, IP address classifications. So Class A, Class B, Class. So what is the size? We can remember that one. Then IPv4 uses a 32-bit and 4 bytes addressing, which gives the 2 4 32 addresses. So IPv4 address are written into the dot decimal notation. That is 192.168. So downside I have shown you here. See that 192.168.9. Like that dot notation, which compromise the 4 octets, octet, that is octave number. That the address is expressed individually in a decimal and separated with the periods. So for instance, we have 192.168. So this is the IPv4 address again. So this is a thing I told you. I will show you. So that version will take the 4 bits length and HL length. So header length will take the 4 bits. Then the type of service will take the 8 bits, and the total length will be take the 16 bits of length. Then here the identification will take the 16 bits, and the zero for this is a fragment check is that is a 0 bit, 1 bit, 2 bit, and like that. We have various formats are there. That is the total, which will take 13 bits, and the time to live it will take 8 bits, and the protocol which will take 8 bits, and also. So based upon this, we are going to be explain this. So that's why I mentioned again what is the total size. So total 20 bytes to, that is we have the data we may mention 20 bytes, so that is a 65,536 bytes we can use as a data here. So one message header, the message header is going to be followed with this much of data is can handle. So that is the meaning of this one. So we will see one after one what is the version, what is the information on version. So the version of which type of version we are going to be used, that is IPv protocol 4-bit version, which is 4 for IPv4. Then H length, that is IP header length, the 4 bits, which the number of 32 bits word in the header. The minimum value of the field is 5 and the maximum value is 50. So the types of service, low delay or high throughput and reliability, the 8 bits of length. The total length is length of the header. So that is the data is length of the header plus data. So the total is 16 bits, which has minimum value is 20 bytes and the maximum value is, I already told you, one message definitely one header can definitely handle the 20 bytes to 65,535 bytes of data can handle one message. Then the identification, a unique packets identification, the group of fragments with a single IP address, IP datagram, that's 16 bits, and the flag bits. So flag bits are 1 bit each, and the reverse bit must be 0, and don't fragment. So that is a various mentioning whether 0, 1, or 2. So based upon the number, we can mention that whether it is reverse, it is don't fragment or more fragment bits in the same order or different order. Based upon this flag bit, we are going to be mentioned. Then fragment offset is represent the number of data bytes head of the particular fragment in a particular datagram, specified in the terms of number of 8 bytes, which has the maximum value of, that is 65,528 bytes. The time to live when the data gram also have lifetime is the 8 bits. It prevents the datagram to the loop through the network by restricting the number of hops taken by the packet before delivering to the destination. So before then, so how much time it has to take. So that timing information, the lifetime, whatever, that timing information is going to be mentioned in 8-bit size. So it prevents the datagram loop through the network for restricting the number of hops. That is a number of hops means from where to where, so that we know that host to host communication. They here also hops are we can take as a node by packet before delivering the destination. So how much time it has taken. So how much time it has received by the destination. That information is going to be mentioned. Then the protocol. The name of the protocol which used to data is be passed 8 bits. That is the protocol which the protocol we are using. Then header checksum. The 16 bit of header checksum for checking the errors in the data header. It is going to be shown. So then we have a source address, source IP address, that is the 32 bit, and the destination address we have 32 bit again. So the optional information such as source, root, and record. For example, which path it has selected. That path may mention or may not mention. That is the optional phase we are going to use. Used by the network administration, check whether the path is working or not. So for network administration, we need to check whether the path is properly there. That is going to be taken by the. So this is up to IPv4. So afternoon we have a class again. There we will see IPv6. Still, anyone having doubt, you can ask.